So to finish this up, let's look at part C and part D where we've constructed the interval in the last video, a 98% confidence interval. What we're going to do is we're going to interpret it and then look at part D. So how do you interpret this interval that we just constructed? Well, again, we just write it out in the same format we did on the previous exercise. We are 98% confident that the interval from 28.7, oops, probably need to write that a little better, from 28.7 to 35.1 contains the population mean. And that's how you interpret that. Again, it means just if we were happy to take from this population of race car drivers, if we took hundreds of intervals of size 15, approximately 98% of those intervals would contain the true population mean for the ages of all race car drivers. So again, does that mean our interval contains it? We can't guarantee that it does, but we're fairly certain that it does. But we can't guarantee that 28.7 to 35.1 in that interval would be the true population mean. So the true population mean of all race car drivers of their ages. But we are fairly confident that's in there. So last part says, your friend who is a huge racing fan claims that the average age of all race car drivers is 26 years old. What does your data say about this claim? Well, he's claiming, again, what his claim is that he's claiming that the mean, the population mean is 26. Well, as you can see, 26 does not lie in our interval. So even though we can't say that for sure 100% that the mean is not 26, we can be fairly confident that the data seems to disprove your friend's claim. So how we would write this is the data seems to disprove your friend's claim that the average age of all race car drivers is 26 years old. Okay? It just seems like, since again, as long as we followed everything we could and did everything correctly, that it just doesn't seem like, according to our interval, that his claim is correct. And now we're done with example 2.